One of the things we as teachers need to start to do is point out to children how much they do know, instead of showing them how much they don't know. Hi, my name is Barbara Goldstein, but my grandchildren call me Beeba. I've been teaching for 53 years, and now that I'm retired, I wanted to share some of my best practices and teaching ideas with all of you. One of the things that always bothered me the most in schools was that we never were assessing what children knew. We were really assessing what they didn't know. When we give a test, we don't mark the things that they know right. We mark the things that they don't know wrong. And you'll hear students say, I got 3 wrong. Never, I got 27 right. We also use red pens. Boy, I wish we could throw away those red pens. I taught a class for prospective teachers, and I gave them an essay assignment. And when I returned it, I had written all positive comments only in red ink. And when I returned those papers to the students, as they were getting them and saw all the red ink on their papers, one by one, they turned pale because they expected negative comments. Blue ink, black ink, green ink does the same thing as red ink. And I think one of the things we as teachers need to start to do is point out to children how much they do know, instead of showing them how much they don't know. In order to do that, one technique that I developed to use in a class every single day for at least one question is called wrong answer, please. Let me give you an example of it. These might be the directions that were on the blackboard. Select one answer that you know is wrong and explain why it's wrong. Let me tell you what the reaction was in one of my basic math classes when I put these directions on the blackboard. One student raised their hand and said, Miss, you want me to find a wrong answer? I'm good at that. And immediately I knew I had found a good technique, because the participation of students in my class tripled, because finding a wrong answer is so much less threatening than finding a right one. But it goes beyond that. Let's consider these questions. The first one says, change 5/6 to a percent. And I'll give you all a minute to look at the choices, and please pick one that you know is wrong. And in your own head, explain to yourself how you know it's wrong. Well, some person might have picked 5.6 and just said, oh, miss, they're using the same numbers, they're just trying to trick me. And my response would be, you're absolutely right, and that is a wrong answer. As the season or the term or the semester would progress, I would ask for a better reason than that. But for right now, that student is right, and he deserves to be told, good job, great answer, you're right. 5.6% is a wrong answer. Then another student might look at 56% and say, I think that's wrong because it's too close to half. Very interesting. Can you explain that more? Well, 5/6 is almost everything, because it only takes 6/6 to make the whole pie. So 5/6 is almost everything, and 56% is certainly not almost anything. Because if I got 56% on a test, I wouldn't be happy. That's an excellent answer, but it also shows me several things that this student knows. It shows me that he understands the concept of fractions, that 5/6 is almost a whole. It shows me that he understands the concept of percent, that 56% is only about half. And even if this student has no idea how to change a fraction to a percent, I just learned a lot of things that that student does know. And another student might say 22%. It's much too small. Yes, Good, that's a great answer. What I wanted to point out to you is that a whole bunch of students in this class could have gotten the right answer and know that they participated correctly in a math lesson without even having a clue how to change a fraction to a percent. But they're more likely to listen to me now when I show them how to change that fraction to a percent. Let's look at the next question. Find the square root of 70 to the nearest tenth. How do you do that without a calculator? All right, well, somebody might say, it can't be 35 because you're trying to trick me. That's just half of 70. And square root doesn't mean half. Very good. They might not know what square root means, but they know it doesn't mean half. Then we might have somebody who says, well, I know the square root of 81 is 9, so 9.2 has to be much too big. Excellent. And then we finally could get to, well, how are we going to choose between 8.4 and 8.9? Think about the level of critical thinking and deductive reasoning that we're now using in this discussion to find the right answer, even if we don't know how to find the square root of 70. Just to not leave anybody hanging, 70 is between 64 and 81. The square root of 64 is 8, and the square root of 81 is 9. So it's closer to, 70 is closer to 64. So my answer must be closer to 8 than it is to 9, which leaves 8.4 as the answer that is correct. But think about how much mathematical discussion you were able to have with even the slower members of your class by asking the question in this way. And just to show that this doesn't necessarily only apply to math, I included the question, Chris injured his leg. The doctor said he hurt A, his collarbone, B, his funny bone, C, his intestine, D, his femur. I think everybody would agree that even without ever knowing the vocabulary word femur, we could all get there by eliminating the other choices. What are some of the advantages to this? Well, first of all, we know that it accelerates class participation. Just by the reaction of the student who said, oh, I'm good at finding wrong answers, we know that. We also can see that students are less afraid to show you, hey, I know it can't be 5.6, they're just trying to trick me. That's perfectly acceptable when you first start this kind of lesson. I would say that using wrong answer, please, could be your do now question at the beginning of every lesson, or it could be your review question at the end of every lesson. But if you use it every day, your students are going to develop critical thinking skills. They're going to gain confidence in what they do know instead of always emphasizing what they don't know. They're going to participate more. Wrong answers have value. They have value in developing the process of elimination, which all of us would agree is an important test-taking skill. I've made a list of some of the advantages of this method, and I think we just went through most of them. It increases participation because it's much less scary. It's much less scary. You have 3 chances out of 4 of being right instead of 1 out of 4. It promotes mathematical discussion, as you saw when we were discussing fractions and percents and square roots. And it's a good assessment tool for the teacher to see what does this student know. The only thing that we test on most of our exams is rote memory. And rote memory is good. It has its value. I definitely want my doctor to know the names of all the bones in the body. However, I also want him to be a critical thinker, a troubleshooter, and be able to analyze and use deductive reasoning. These are skills that this method, wrong answer please, encourages. It also develops test-taking skills, as we said. And the most important thing is it builds confidence. It lets every student in your class know that, yes, they do have something that they could contribute to your lesson. So this is the first Beeba's best practices that I wanted to share with you. I call it wrong answer, please. And the only caveat that I would give you in using this is when you make the choices up for your question, make sure that you're keeping in mind that you want the students to be able to pick the wrong answers. So set up your choices accordingly. Thank you. If you enjoyed this video, please like it and subscribe to my channel. If you want any additional information about Beeba's best practices or any other teaching techniques, please don't hesitate to use this contact information. Thank you for watching.